Now we will show how the data can be directly received in Matlab, and the example problem will be a position stabilization code running on the MIP robot, which will transmit all 7 states and the 2 applied motor voltages and the 2 battery voltages. So on a total 11 states are transmitted through the ZigBee module. So there are 2 functions which are used to receive the data. First is in a simplex mode, initialization of the serial port. Let's say the current port which has been used is COM5, and it has been set to 19,200 baud rate, and the buffer size is 24, which means 12 integers are received including the frame divider. So 11 states and 1 frame divider, and this has been run once. This program should not be run more than once, because it will, once the serial port variable S is cleared, the Matlab has to be exited and reopened again. So to prevent that, this code is run only once. And if the baud rate needs to be changed, it can be changed only using executing these 2 things, or the buffer length or other parameters. The other code is where the data is continuously received. So here there are various synchronization loops, where there is one loop where it keeps checking whether the frame divider keeps coming. Otherwise it says an initialization error has occurred, and once that is crossed and the frame divider is received, in case there is a data error in any particular frame, then again there will be an error saying error 1 which will be displayed, because there could be a data transmission error in the frame divider at some particular instance. So, and then once the data is proper, all 12 data is read and it is stored into an array X, and the process is repeated continuously. So live data viewing has been avoided because the data plotting functions of Matlab introduces significant delays and the data packets get lost. So in this program, the data is completely stored, and after the data storage is completed, we can plot it through the plot functions. So now we will show the actual receiving the data and plotting it. So we turn on the system. So after some delay, these states are now been transmitted. Now we will start receiving the data through this function. We run the function. There is no error which has been encountered, which means the frame has been properly synchronized. And once the data is continuously being received, the data received LED glows up. So now we will change some states of the system. So the pitch angle is first made positive, then negative, then we give some oscillations. Now the wheels are rotated. So this particular wheel is rotated, which means the robot will go in a clockwise circle. Done. So now we stop the receiving function. Once the receiving is stopped, the LED automatically turns off. So now we will plot the pitch angle, which is the fourth state, and in transmission a scaling of 1000 has been provided, so hence we divided by 1000. So, and the data can be seen. So first the pitch angle goes positive, the plot is in radians, then it goes negative, then we provide some oscillations. So this is the pitch angle. Similarly, pitch velocity can be plotted, which is the fifth state. Similar to earlier, first the pitch velocity goes positive to go front, then negative, and then some oscillations are there. Now the X versus Y can be plotted. As it can be seen, the robot started here and it went through a circle, almost a complete circle. You can even plot the heading velocity, which is the sixth variable. So, and since the motion which was given was jerky, but still the robot was moving forward, so the velocity is always positive. But since the robot has gone clockwise, the turning velocity omega will be negative, as shown here. So it starts at 0 and keeps turning clockwise. So this is how all the states are stored. The states are stored in X, which is a 11 states totally, including the motor and battery voltages, and for a total of so many samples. And this is used to totally receive all these states and store and plot. The same experiment can also be, the same programs can be used to also obtain the formation control data, but additional code is necessary to interpret the flags of all three agents and separate the data out.